桌放就非常有，不用了。
Okay, this is right before the break. We show you the behavioral function implementation, and there are a bunch of them, but I want to go for the simplest one, which is constructor. By the way, I will upload this file. I know I'm typing some like instructional note on those files. So this is a constructor, and the name of the function, and sometimes we call it name of the function, or it's a member function. It has two parts. It has a, let me put it here. It usually started with a class name. If it's this function belong to a particular class, and then have two columns, and then you have a function name. So this is different from the regular C function. Regular C function, you only have a function name. You don't have the class name with two columns. Okay, so now if you see in the C++ program, anytime you see a string followed by two columns, that means the string before this two column must be a class name. Must be a class name or class identifier. Okay, so that's the name. And now let's actually compare the .h file with the .cpp file. 1 second. If you come to here in the GPS.h in the top window, you can see the constructor looks like this. The first constructor looks like this. So which means that this constructor does not return anything, does not take any input argument. So is exactly match the one in the button. Like this. Okay, so this one match exactly this one. If you think of, when I say the word match, I mean match with the function name. And the thing is, because this definition was within the boundary about the class GPSDD declaration, so they will know that you're supposed to add the GPSDD. Otherwise, I don't know whether this particular function belongs to this class. Okay, that is just a function name. But also their signature, this is sometimes we call function signature match, because the return type is nothing in the declaration, and the return type of this function is also nothing. So that's a second match about the return function. The third element it has to match is the number of argument and the argument type. And there's a 0 argument, and then this one has 0 argument. So essentially, this declaration match perfectly with this. By the way, for the compiler, for the linker, when they want to link things together in C++, it has to match all three perspectives: the function name or the member function name, the return type, and the third one about input argument number and input argument type. If they all match, then this one will match this one. Okay, and now let's take a look at the implementation of this function. The implementation of the function is just assigning the two attributes, latitude and longitude, to be 0. Okay, so now we introduce another keyword, which is called this. And I assume you're familiar with this sign. Dash greater than, this means pointer. Means this pointing to the latitude attribute. this pointing to the longitude attribute. And those two attributes, I assign the value to be 0. Okay, so that's what this two. But you might still confused about why I'm doing this and what is this keyword represent. Okay, I'm going to actually type it up about what's going on here. So I'm going to do this. When an object is created, there are a few things that will happen in the following order. The first thing is that it will need to identify a chunk of memory. Of course, it needs to be big enough to use all the resources for this object. Okay, so later I will tell you what kind of resources I need to have, because sometimes it's not easily identified as, say, the attribute themselves. I mean, if it involves virtual function, it might need to involve some other element as a resource. That's why I said virtual function is difficult, because it actually creates a lot of complicated situation. But don't worry about that. The first step is you have to find a chunk of memory that's large enough to host this particular object that you're going to create. And the second part is that the first byte of the address of the first byte of the chunk or the object itself, because you're going to put object in this chunk. So I say slash object, the address of the first byte, I actually call it this. Okay, so in other words, what is it this? This is the address of the first byte. Or this is the pointer to the object. And by saying pointer, it basically means the address of the first byte. So then that's the address being assigned to be this. And then the third thing is going to happen. After you do the allocation, you do the following, is that you will call the constructor, one of the constructor. In this case, is the constructor that take a 0 argument. I mean, in this definition, I have two constructor. One take a 0 argument, one take a 2 argument. So this one is actually called one of those. But the code I show you here is actually for the 0 argument. But take a look at what it is. It's essentially saying that, hey, I have a pointer which shows the first byte of the object. And then within the object or within the structure or within the class, there is an attribute called latitude. And because I'm a first byte, I'm actually pointing to the latitude. That means, okay, the other thing I should actually say this is that when I define the class, I said the class has 2 attributes, which means that every single object I created with the class GPSDD, they will have these 2 attributes. So this to the latitude represent the attribute of latitude within the newly created object that we just done. Okay, so that's the constructor. The constructor is doing something very simple. We call it initialization. We want to initialize the value of the attribute. Okay, by the way, you can put anything you want in constructor as long as logically it makes sense. You can put anything in the constructor. but usually we don't put it too complicated. And let me show you another example about the second constructor. It's the same thing, but now it has two arguments. The first argument called arc latitude, the second argument called arc longitude. See what I did? I just assigned r latitude to this to the latitude, and r the longitude to the this to the longitude. Okay, so this is now you learn what we do. As an example, in constructor, constructor is called after the memory was allocated, and then you use this as a pointer to pointing to this object that you just created, and then you can actually initialize the value to whatever attribute you want to do. So I have a two-way to construct a GPS object. One is just set the GPS location to be 0, but the other one I set it to be whatever value I want to set initially. I mean, depending on your application. Okay. Any question so far with constructor? Yes, please. Okay. ARG is just a name. So this name, I don't have to call ARG latitude. I can call it AAA, or I put nothing. Okay, so it's a you can define. But I want to say that this is following your question. This is something I call convention. The convention is important is that I sometimes want to, okay, let me actually put down the code, tell you what, I can write the code totally different. This is original one, I get rid of this, and I can do this. And I can do this. And over here, by the way, I can do this. I get rid of this too. And here, what I can do is I can do this. I don't have to write this. I just do this. Technically, by writing it this way and this way, in most cases, they're probably semantically identical. Okay, but I do advise, if you see my code, if it's a member attribute, I always put the this in front of that for the following reason. Because at this moment, you look at this code is pretty small. So what is a latitude? You know latitude is an attribute. But when the system gets more complicated, when you have multiple programmer, if you see this latitude, you're not sure whether this is a member function. By the way, the following still work. Let me actually show you an example. I can actually define a double. This is a bit advanced, but I want to just tell you that how ugly the code can be. I actually can write this piece of code looks like this, and it will still work. But this particular latitude is not going to be referred to the member attribute latitude. It's going to refer to a local variable latitude. Okay, those two are somewhat different because C++, at least the version I use, allow me to define a local variable with the same name of the member attribute. That's why when I do this, I'm basically telling the compiler, I want that particular member at latitude, not the local variable latitude. That's why I always use this to make sure that there's no other programmer, they define a local variable that's actually using the same name of the member function. A member attribute, okay? So later we'll see when we run the program, okay? So that's basically the GPS DD constructor. Any other question? Okay, let me show you the other two pieces of function. This function is called get latitude. Get latitude is very simple. I just say return this latitude, return the value of that attribute. And then get longitude is return this longitude. Okay, I'm not going to tell you the distance, but I will go over the code very quickly. It's actually in the GitHub. So to calculate the GPS location, it has certain kind of way to calculate. And here is the algorithm. And I actually copied the code from this particular user who contribute this. And you can see that this part of the code is quite complicated. It's using a function called geodata source distance, using two pair of latitude, longitude, and basically a unit. And then, but the member function I have over here is a distance. You see that again, the function is called distance, but I actually add the class name GPSDD. And then inside here, I essentially just call another function called geodata source underscore distance. I'm actually calling another function as the implementation of this particular member function. Okay, so that's but geodata source distance was an open source piece of software to calculate the distance between two pair of GPS location. You don't need to know the detail at this moment, but that's essentially what's going on. Okay. Okay. Any question about? So now I taught you two things. One is called GPSDD. Oh, sorry, GPS.h. One is called GPS.cpp, which is have everything. And now we're going to run the program. We're going to run the program. Okay, by the way, to run this program, I have a separate directory. I think it's easier to just derive, to point you to that particular directory. There is a directory. Where's my GitHub? Okay, my GitHub is here. I have inside my GitHub directory, if you go to github.com/sfelixwu, there's a one repository called CPP01 person and thing. And inside person and thing, I have a bunch of program, which is the smallest one, which I have GPS.h and GPS.cpp, which is more or less the same as what we just showed you. Okay, so now we're going to use that directory, try to demonstrate for how things will be put into action. Okay, not just talking about code itself. Let's try to run it. Okay, so if you do that by download the zip file, you should have this directory called CPP01 person and thing. Okay, it's more complicated, but I'm going to simplify this. First, I make a clean. I always do that, and then I make. You can see that it's make file. It actually compile a bunch of code, including GPS.cpp. Okay, so now I want to actually do one little trick I mentioned 5 minutes ago, is that the confusing ambiguity between a local variable and the member, they are actually the same name, which is the latitude. I want to just test it out. Okay, I tested it out. I feel like a few years ago, but I don't know whether C++ has changed in some perspective. But let's try. Okay, by the way, you probably heard me say more than once. Very important in programming, always have to run it to know the answer. Don't believe your instructor. So I'm going to gps.cpp. And inside here, you see what I'm going to do. I'm actually going to do this. I'm going to say double latitude. So I define a local variable within the constructor with the same name as the attribute of the class itself. Okay, and then what I will do this part is I will then directly to say latitude. Okay, so I just directly say, let's try to compile to see if it can allow me to actually build my program. You see, it works. It doesn't complain. And let me do that. Let me do it again, make it clean. So it doesn't generate any warning or error for me to define a local variable with the same name as a class attribute. So in other words, this is confusing. If we go back over here, so let me ask you this question. If I write a piece of code looks like this, so when I say this particular statement is an assignment, so I assign the value of arg underscore latitude to the variable latitude. Then I want to ask you for you to actually tell me whether this latitude refer to the local variable latitude 2 lines above, or this refer to the member attribute latitude. Which one do you think that refers to? Anybody? Do you understand my question? Okay, by the way, I can do this as well. Let me do to just make it consistent. I can do this as well. I can just say longitude like this. It still work, doesn't matter. So this itself is a redundant in some sense, okay? So now my question is, if I write a code this way, I mean, by the way, I strongly against writing code this way for readability, confusing. But this latitude, is this referred to this latitude? Or is it referred to the latitude that's defined in GPS.h? You can write the code to actually verify, but I can tell you that this latitude referred to this latitude. But this longitude referred to the longitude defined in the class GPS. Why is that? Because it's a scoping. So in compiler has a scope. In the scope means this latitude is within the closest scope you can find is this one. So the compiler will try to find the closest match to where you use this identifier. So therefore, this latitude is actually going to be this one. But this longitude, because I didn't define a double longitude, it will actually go to the class definition. But if I do this, if I actually do this, if I do this, then this latitude will always go to the class latitude attribute, not to the local variable, because this local variable is not this. It's actually a local variable. So that's why I mean, programming sometimes is about communication. You want to communicate to other programmer, communicate to yourself about exactly what you want to put down. Therefore, you want to be as explicit, as clear as possible about how you want this particular variable referring to. That's why I always prefer to say this in the program. Okay, any question about this? Okay, good. Let me actually change this back. I don't need this. And I want to put this back to be consistent. Still compile. Okay, so now I'm actually going to run the program. The program is called test theme person. So / test theme person. Okay, it basically generates a bunch of things, but let me just show you how the result. It basically say the distant one is about 9 miles, distant one, 9 miles, a bunch of this. But then there's a distance from New York to Davis is about 25,16 miles. Okay, let's actually do this. I want to see where is NCKU. I want Google Map. Can someone help me to find out what's the GPS coordinate, latitude and longitude for this building? Anybody want to find that? How do you find that? I will go map. Okay, I'm here. Oh, wait, that's good. I don't want this. Can you get rid of this? That's where my wife is here. Okay. Here is wait a minute. No, I don't like that. I'm gonna go up. Okay. I believe this one is our location. Okay, this is the electrical engineering. If I do this and someone type it up, I will do this. I cannot. Oh, it has been copied. Okay. So I'm going to go back to change the program. Max test person and thing.cpp. Okay, I'm going to actually define another one called GPS EE building 1 I9. And then I'm going to V this. Okay, so you can see that now I'm actually trying to create an object. By the way, if you remember, this is how you write the C program. You still need a main program as entrance point for any executable. So now I try to create an object. So how do you create an object? I mean, if you create an integer, when you want to define a variable integer, let me show you how you can do that. If you want to define integer, you say integer x, right? So you give the type about that variable, and then x is the variable name. So in object-oriented, it's the same thing. I define GPS BD, which is a class. Remember I say class is a type. It's a complicated type. And then I give the whatever name, I say GPS1. But in this case, I didn't invoke the constructor. Well, in fact, I did invoke the constructor implicitly, but invoke the one that's actually with a 0 argument. Oh, okay. You know what? I'm going to do this. I want to tell you what I can see which function I'm invoking. GPS, I will just print it. I would std cout. This is constructor 1. Okay, so I know I'm actually invoke constructor 1. And then I have constructor 2. This is I invoke constructor 2. Okay, so I have three GPS object I just created. So now I can just exit the program. Just want to construct 3 objects and then gone, okay? I make, and now I can execute the program. You see, I'm actually invoking constructor 1 and then constructor 2. See what I did? Because the program I have the first 3 lines. Remember, I just do the 3 line and I exit the program. Okay, by the way, you should test your program, small pieces, and just exit when you realize. You see that I have this 3 line represent how I create 3 GPS objects. The first object is called GPS underscore 1. The second is GPS home Woodland. The third one, the GPS electrical engineering building 1 in Tainan. And this one, it doesn't take any argument, so it's actually match the constructor 1. And this 2, I offer 2 constructor, so sorry, 2 argument, so you match the what I call the second constructor. Okay, that's great. All right, so that hopefully I convince you about how you can construct an object using GPS DD. Okay, then I'm going to skip this part. I remember I was teaching. So, okay, this one is the GPS location for UC Davis, and I have a distance. Okay, now I want to do a distance, but I want to do a distance in this way. I will still do exit, -1. And I want to say distance 1 is equal to GPS EE building 1. Is that right? What's the variable? I forgot. EE build 1 Tainan. EE build 1 Tainan. And then with the distance called TLC UC Davis. And then I'm going to get rid of this. And I said distance between Davis, California, and NCKU. I'll just say the distance between UC Davis and NCKU is whatever number of miles, which I just compile. I just use this member function distance. Okay, you see that this is an object. The object is I just created, and the object has a member function called distance. So how do I call a member function? Is that the first I have to create this object called GPS E building 1 Tainan, and then using dot distance, which means that the function within that object, and then the argument is another GPS location, which is GPS TLC UC Davis. And this should give me the result is the distance between whatever the calculates between those 2. Okay, let's try to run this to see what we got. Okay, so this is the object. I create 4 objects. The first one is the dummy one. And then I create a Woodland one. I create a Tainan NCKU. I create a UC Davis. And then the distance between UC Davis and NCKU is about 6,594 miles. That's how we count. Does that sound right? From California, the middle California to Tainan is about 6,600 miles. That sounds about right. So if you can calculate this, you actually can already start doing a lot of things. For example, you want to calculate what's the distance between Tainan and Taipei, or what's the distance, the driving distance between Tainan and Taipei. That could be the Google's problem. But if you can solve this problem, you can already solve a lot of issues. Okay, any question so far? So, any question? Okay, I want to recap what we did. This is our first introduction to a concept called class. And the class, as I mentioned earlier, is a type. And based on this type, we can create objects. And then based on the object, we can interact with this object. In this case, the interaction is, there is a member function called distance. If I give this object another GPS location and calling this function, member function called distance, then the behavioral about this function is going to return to me the distance between the object's current location and the location of the object as the argument. That's actually, I want to go back a little bit careful. I know this might sound horrible to some of us, but I want to go back to the GPS CPP. And I want to just show you the distance function. Okay, look at the distance function. So the distance function is like this. Let's focus on the interface about this function. This is the member function. Why is that? Because I declare with a class name, colon, distance. And then the function is going to return based on the declaration in the GPS.h. So GPS.h by convention is a declaration. I declare that particular class interface. And the return is going to be the double, and argument is actually another object of GPS.dd. So it's possible of a member function, one of their argument is actually also an object. They're both following the same spec, which is GPS.dd, but they might be different object in this case. That's why I call this is another, just a name I call it. And I have this name, and then you can see how I calculate the distance. I calculate another dot get latitude. I have another as an object. I use that member function get latitude to get the latitude component. And then I use another get longitude, which is the another member function to get the longitude value. I'm doing the read. And then for my own latitude and longitude, I use this. So this means my own coordinate. This two represent another's coordinate. And I fit in all four coordinates with the character m. That means I want to calculate with miles. And I can put k represent is kilometer. I mean, depending on what's the, but that's being defined as the function geodata source distance, which is written by somebody else. Okay. So that's how the whole thing putting together. So this will be the first class. If you have never written a C++ program, this will be the first time you actually, from first line to the last line, how you can have a class. And then what we did is in the test program is basically show you that, well, how you can construct an object. Once you have an object, you construct. By the way, there are multiple ways to construct the object. I'm showing you the simplest way to do that. Okay, this is the simplest way to do that. And then inside here, I actually, once I create this object, I can just actually call the function, call the member function by saying that GPS EE1520 Tainan dot distance. That means I'm actually calling the function, the member function on that particular object I just highlighted, which is the EE1520 Tainan. Okay. That's a simple program. Is a little bit complicated than Hello World, but it's almost like a Hello World of a C++ class and object. Okay. Any question? I still have about 10, 11 minutes. I can actually try to talk about homework assignment number 1, but maybe I can wait until Monday to do that anyway. I want to make sure that at this moment you're clear about the basic idea about class. Any question? I have a chocolate. Anybody want to ask? Anyone will eat chocolate? Nobody want to eat chocolate? Okay, good. Anybody else want to eat chocolate? I just want to test whether you're a student or you're a professor, okay? So we have a lot of professors over here. Can I throw it to you? Are you good in baseball? Okay, I'm sorry. Unintentional. You guys are good. Okay. Okay, anybody want to ask questions? More chocolate. I still have some chocolate. Okay. Okay, good. We have some student here. They're still enjoy life. Yes, please.
match 的部分我没有了解，所以你说这个一分四十几画到这边的决定好没有到。
Okay, so let's try to see this. Okay. Okay, the question is about the function signature. It's about whether GPS DD. Okay, that's a good question. Let's try this. So let's look at this. Assuming I have this function, I will use GPS DD distance as the example. Okay, this example right now, I said GPS DD colon distance. That means I'm saying that this function is actually belong to this class, GPS DD. Let's do this. I leave it out. I actually remove the class. I do this. I only do this. Okay. So what will happen if I do this versus the earlier version about this? If I do this, this distance becomes a regular function, a regular C function. Has nothing to do with C++ class. It's just independent. Okay, so let's try to compile to see how it works. Okay, I can still do make gps.o. So I'm actually compiling. Oh, I already have. Oh, because it's a this. Okay, so I have to change it to make it compile. So the error message is because this is not a class member function. So it's not belong to the class. You shouldn't have this. That's why they're actually complaining. So what I'm going to do is just for the sake, I'm going to get rid of this and get rid of this. And then I'm going to define double latitude and double longitude. Okay, I'm going to define this too, and then I'm just doing like this to make it compile. So now you can see I can still get it compiled, even I remove the class, but it's actually defined a different function. So now let's try to make it again, make the whole thing. Okay, you see, I'm trying to type it. Okay, let me do it. This might be confusing. Let's try to make it clean and then do whatever I'm doing. So I'm actually making the whole thing. This view line is as before. When I compile individual file, gps.cpp, testing person, they all compile fine. But at this stage, what they try to do, this line is important in the make file. It try to link all the .o file together into this executable called testing.person. But then it's basically saying that you see what it says, the message he said, undefined symbol. Undefined symbol for what? Undefined symbol for GPS DD colon distance. Because why? Because I never defined that. I removed GPS DD, so missing one function. So although it passed the syntax, whatever stage, when they want to link the code together, they realize I'm missing that one. Because why? Because you see that it's a reference from main in test thing. And what was that? Because this function in the test person in the main, I actually call that function. I call that function here, this line. Remember, I use this object and then dot distance. So essentially, I use that member function, and that member function is declare it's okay, is in the GPS.h file has that declaration. But the thing is that it doesn't, the linker cannot find anything. So one of the things I might be able to do is, assuming I just kill this line, I don't have this line, means that I never use that member function, even though that's actually in the declaration. Now let's try to see how it works, because I'm actually have a function I never use that one. Now it works. Okay, so you see what I did here? I kind of define a member function called distance, but I remove its real implementation by removing the class name. So it means that it's no longer a class name. And then if I use that function, the linker basically say, hey, you want to use that function, but that function is never defined in any of your .o file in the linking stage. Okay, then to just show you, illustrate the point, I'm not saying this is the right way to do it, is just try to avoid the problem. I actually remove that line, that particular distance function, I never call it, then the linker will be able to let you go. So essentially what the linker is doing, there's a few things, a few messages here is important. Number one, you have to put the class name in front of the function name to be a member function. That's number one. Number two is that you can declare a bunch of member functions, but some of them you didn't have implementation. Means that you thought you want the person has this interface, but you never really implement the behavior itself. You just have a declaration. By the way, you should know when I say declaration versus definition. Declaration means that I said this function exists with certain function signature, but the real implementation is in the definition in the .cpp file. Okay, so in C++, it's possible you have something declared but never implement, and it still work, as long as you don't use that function, because the linker is going to check which function you use, and then try to figure out that where's the code I should execute that one, and then to put these things together. Okay. Okay, I think that we're about good closure. Any other question? I still have like 2 minutes. Any question about what we learned today? So I really want to make sure that you learn the class. Okay, the first class, how to create a basic object, constructor, and how to define a member function and how to call it. Let me actually write it down, my PowerPoint. I want to make sure you know what you learn, and then we'll continue. This is the basic one, then we'll get more complicated cases, okay? This one, yeah, that's good. I want to say what we learned today. Hopefully. The first one is a C++ class. And then we have a both declaration, which is the .h file, and definition, which is the .cpp file. And I hope you learn how to about constructor and also how to create an object. And how to call a member function. Okay, that's pretty much we covered today. So we will see you on Monday, and you guys have a good weekend.